In this lecture, we're going to learn about enum classes. Enum classes are types you can set up in your C++ programs to represent a range of values. Suppose, for example, that you want to represent months in your C++ program. It is possible to set up a series of variables, for example, std strings to represent each month. For example, have a variable for January, have a variable for February, and all the way to December. But that's not really easy to work with. We can set up our own type like we see here. For example, we can say enum class and say month, and this is going to be our month type. And if we put a pair of curly braces like this, we can specify possible values for this month type. Once we have this, we can create variables of this type like we see here. We can say month and put in the variable name, and we can initialize this guy with values that we have inside here. And the syntax we use, we have to specify the type. You see, we have month with uppercase M here, and we say double colon and say whatever value that we want to initialize our month with. All these values we have between these curly braces are called enumerators. And we can initialize our variable here with any enumerator in here. Once we have our variable here, we can use it in our program to do whatever it is we want. Here you see that we can't really print this type because the compiler doesn't know how to print it. And this is by design. But if you really want to see its value, it is possible to take this and turn this into an integer. For example, if we try and cast this to an integer, we're going to have a 6 printed out because this is July. So why are we able to do this? The reason is each enumeration is represented by an integral value under the hood. So we can really look at our months like this. January is going to be represented by 0, February is going to be represented by 1, March is going to be represented by 2, and we can keep going like this until we hit December, and December is going to be represented by 11. And this is by design. Enum classes really are integers under the hood, and you specify a range of integers that represent whatever values you would want to represent in your enum class type. Okay, by default, your enumerators are going to start by 0 and keep growing until you hit the end of however many enumerators you have in your enumerator. But we can customize this. For example, for our months, I think it is more logical to make January be represented by 1 and keep going until we have December represented by 12. And we can do it like this. So we can say January equals to 1. And now if we take our enumerator and cast it to an integer, we're going to see that 1 is going to represent January, February is going to be represented by 2, March is going to be represented by 3. And if we keep going like this, we're going to have December represented by 12. If we keep doing it like this. But you don't have to just specify the first year. If it makes sense for your application, for example, you can change August here to represent 18. And if you do this now, September is going to be represented by 19, October is going to be 20, and we're going to keep going until we hit the end here. So the way the compiler really sees this, if it sees that you have specified one enumerator with a custom value, it's going to keep incrementing after that. So for February here, we're going to have 2, March 3, but when we hit August, we're going to have 18 for August, but September is going to be 19, October is going to be 20, November is going to be 21, and December is going to be 22 at this time here. This is how these things work. Okay, we can really customize our enumerators to work however we want. We can even use negative values to represent our enumerators, and any following enumerators are just going to increment on that negative value. You can do this if it makes sense for whatever application you are designing. One other thing I want you to know is that we can have multiple enumerators for the same value. So for example, here we can use Jan to represent January and have a full name here for January. And we have to help the compiler here and tell it that all these enumerators really represent the same thing. And we say that by binding all these two names to one integral value. Okay, so once we have this set up, the compiler is going to know that these two things really represent the same value. So you can use JAN or January in full to really represent January, and we can keep doing this for February, March, and even go up until December if that's what we want. We can also define enumerators in terms of others. If you look here, you see we have January equals 1, but we can even say January equals John. And I think this is much better because we don't have to say equals 1 multiple times. And another benefit of doing things this way is that if later we change the value to represent January, for example, make it 100, if that makes sense for our application, the binding we have here for January is going to pick that value up. We don't have to say equals 1 or equals 1 twice. This is much better, and you can use this if this is really helping your application be done in a better way. Okay, now that we have seen all this, one question you might be asking is, what is the size of an enum? For example, we have set up our month here, which is going to have 12 values, but what shall we see if we try to print the size of this type on the console? Well, the hint is on the integral values we can use to represent our month here. For example, you have seen that we can say Jan equals 1, Feb equals 2, March equals 3, and things like that. Well, the default type to represent these guys is int. And if we print the size of month here, we're going to see the size of int printed out, and we're going to see a 4 on the terminal. So in C++, enum classes are represented by integers or the type of int by default. Okay, this is the message here. Is the default type associated with enum classes in C++? Because integers have this range by default in C++, so this is the range of values we can use to represent our enumerators in our enum class types. If we go beyond this range, we're going to get a compiler error. The compiler is going to say we can't really use those values to represent our enumerators because you can only use the range for int, which is going to be taking 4 bytes in memory on my system here at least. So if you're trying to do something like this, you're going to get a compiler error, and the error is going to be coming from this line here. This value is too large to be represented by an integer in C++. Notice that we can also use negative values to represent our values or enumerators, and this is going to be fine because minus 20 is valid in the range of integers on my system here. Okay, we have seen that the default type associated with enum classes in C++ is int, but you can change that. And the syntax to do that is to say after your type, colon, and you say the integral type you want to be associated with your enum classes. So if we do this, our range is going to be limited to what is representable by an unsigned card type. And we know that this is going to go from 0 all the way to 255. Okay, if you do this, the size is now 1 byte. And if you try to use 300 to represent something, you're going to get a compiler error. Okay, this is really all I have to share about enum classes. They are really flexible to use. We're going to head over to Visual Studio Code and actually play with them. Okay, here we are in our working directory. The current project is enum classes. We are going to grab our template files. Let's do that. We're going to put them in place. And we are going to open this in Visual Studio Code. Let's do that. We're going to open our folder here. We are going to move in the correct chapter, and we're going to open our project here. Okay, our project is open here. We can open our main CPP file and clean it up a little bit. And we are going to declare our first enum class. We can go outside the main function here and say enum class. This is the syntax we have seen. We say enum class, and we give it a name, which is going to be month. And we're going to put a pair of curly braces. And after this, we can put a semicolon. And once we have this, we can put in our enumerators. The possible values for our month are going to be Jan. And we can even put these guys on separate lines to have it aligned nicely. So we can say April, and we're going to put in December here. And we're not going to put a comma after December because it's going to be the last value in our enum class type here. So once we do this, we have our type, which is going to be month. And the possible values are going to be January all the way to December, like we see here. Once we have our type here declared, we can go in our main function and create variables of this type. And we can say, for example, month here using lowercase. This is our variable. And we can initialize it using the syntax. We say the type name and we say colon, and you see that Visual Studio Code has picked up on all the values that we can put in here. So for example, we can go down and choose July. Let's do that. And this is going to be our variable, which is declared. Once we have this variable, we can work with it however we want in our C++ program. The basic thing we can do now is try to print it out. Let's try and do that. We're going to say stdc out and say month. And let's say month and see what we get. And once we do that, you're going to see that we get a compiler error. This is by design because enum classes aren't really designed to be printed out on the console. They are designed to be handled by the compiler when it is really working with your variable. But if you want to print them out, there is a possible way to do this. You can cast this guy to an integer, and we can do that. Let's do that. We're going to say static cast, and we're going to cast this to an int. And what we cast is our month variable here. Once we do this, you see that Visual Studio Code is happy. We can build this and run. We're going to build with GCC. You see that the build is good. We can now bring up a terminal and clear and run Rooster. We're going to see that our month now is a 6. Okay, we can do this. Okay, so this is one way you can set up an enum class type and use that in your C++ program. Let's go on top and say that. Okay, now that we have this guy declared and printed out here, one thing you might really wonder is what is the size of this guy in memory? Let's go down and print it out. We're going to say stdc out size of month, and we're going to print that out. We're going to check this out. If we build and run this, let's do this. We're going to use GCC. The build is good. We can clear and run Rooster. We're going to see that the size of month is 4. And the reason is, as we have seen in the slides, the default type associated with enum classes is int in C++. So let's say that. So in other words, this January is represented by an integral value under the hood. And we have seen a hint to that by printing the month here, which is July. So July is represented by a 6. And really, by default, January here is represented by 0, February is represented by 1, and you can keep going until you hit December, which is going to be represented by 11. So for example, to play with this again, we can change our month here to be January. Let's do that and build and play with us. We're going to build with GCC. The build is good. We can clear and run Rooster. We're going to see that month is 0 because it is January. If we put in February, let's build again. The build is good. We can clear and run Rooster. We're going to have a 1. If we put in a December, we're going to get an 11 because we have 12 elements and we are starting from 0 here. Let's try and put in December, DEC, like we said, and build with GCC. And when we do that, the build is good. If we run Rooster, we're going to have month is 11. So hopefully this proves to you that the default type associated with enum classes is int in C++. But we can change the defaults. For example, January is represented by 0 here, but because we really are representing months in our type here, I think it makes more sense for January to be represented by 1 and keep going until we hit December with a 12. Let's try and do that. We're going to go to January here and add an equal sign and say 1. Once we do that, the compiler is going to know that we want January to be represented by 1, but all the other following enumerators are going to be incrementing on this starting point here. So when we do this, February is going to be 2, March is going to be 3, April is going to be 4, and if we keep going, we're going to hit December, which is going to be 12 by now. So let's try and build again. We're going to use GCC. The build is good, we can clear. And if we run Rooster now, we're going to see that month is 12 because we have December in here. If we try and put in July, we're going to get a 7 because July is the 7th month in a year. Let's do that. Let's say clear properly, and we're going to run Rooster. Now month is a 7. So int is the default type associated with our enum classes, but we can customize which int value is used to represent our enumerators. And you don't have to put one binding like this. You can even put more. For example, if we go to October and say this is going to be a 20 by now, it's not going to be a 10 like it would be. We can say October now is going to be 20. And if we try and print December, we are no longer going to get a 12. We're going to get November is going to be 21, December is going to be 22, because the compiler is going to be incrementing from the previous value. So when the compiler tries to print October, it's going to be 20 because that's what we specified here. But if we hit November, it's going to take October and add a 1. It's going to get a 21. If we hit December, it's going to take October and add 2 because that's 2 spaces from October here. This is how these things work. Let's try and build and change this to December. And we're going to use GCC to build. Let's clear and run Rooster. Now you see that our month is 22, which is really what we expect. So you can really customize your enumerators to be whatever you want. One thing I want you to see is that if you try to go above the range representable by the type associated with your enum class here, you're going to get a compiler error. So we know that the range of an integer by default is from minus something like 2 billion to plus 2 billion or something. So let's try and use 3 billion for October here. Let's do that. We're going to put in a 3 and put in separators and say 3 zeros, a separator, 3 zeros, and a separator, and a separator, another 3 zeros to have 3 billion here. We should get a squiggly line because Visual Studio Code is going to detect that we are going beyond our range. If we go here, we're going to see enumeration value is outside the range of its underlying type, which is int. So this is the error here. And if you try to compile, you're going to get the same compiler error. 3 billion is outside the range of the underlying type, which is int. So we can't really use something bigger than what an int can represent because our enumerators are really modeled on top of int on our system here. This is the message I want you to understand. Don't go over what your underlying type can represent. So we're going to change this, for example, to 300. And now, if we compile, this is going to work because an integer can represent 300 without a problem. We can clear and run Rooster. Now we're going to get 302 because October was represented by 300. So November now is going to be 301 and December is going to be 302. One other thing I want you to see is that you can customize the underlying type that your enum class is using. So if we think that an integer is really too large for our use case, we can change this to an unsigned char, for example. And the syntax to do that is to put a colon after your type and you specify your type. Now we can say unsigned char, for example. And this is going to be constrained to the type of unsigned char. We know that unsigned char is 1 byte on most systems. So this is going to be a problem now because 300 is outside the range of what an unsigned char can represent. If you remember, unsigned char can only represent values between 0 and 255. Let's say that. And 300 is outside that range. To really prove this to you, let's put in 200 and you're going to see that this is going to work fine. The compiler is going to accept it. And if we try and run this, let's do that. The build is good. We can clear and run Rooster. We're going to see 2 pieces of information here. We're going to see that now the size of month is 1 because now we are using an unsigned char to represent values of our enumerators. The other piece of information is now that December is going to be 202 because October is 200. And you can really use all these pieces of information to customize your Enum class types to make them work exactly how you want in your C++ programs. Okay, the next thing I want you to see is that you can have multiple enumerators to represent the same thing. What do I mean by that? Let's go after January here and, for example, put in another enumerator and put a comma here. We want January and Jan to represent the same thing because we want to give our users the flexibility of coming in here and either say Jan to represent January or January in full like this. But right now, Jan and January are really two different enumerators as long as the compiler is concerned. Because it is seeing two enumerators, so January is now going to be represented by 2. Let's try and build this to really prove this to you. So the build is good, we can clear. And if we run roster, we're going to see that month is 2 because January comes after Jan here. So, but what we want is for January and Jan to really represent the same thing. One way we can do that is to add an equals 1 after January. And the compiler now is going to know that these two guys represent the same value, which is a 1. And now we have the option to either use Jan to represent January. If we do that and compile, we're going to get a 1 for Jan. Let's clear properly and run roster. We're going to see that month is now 1 and the size is 1 because it is represented by on sidecar. But if we say January in full, we are also going to be representing a 1. So let's build and try this out. We're going to run roster. Now we're going to see that these two guys represent the same thing. Okay, now that you know this, you can really use these features to make your application work however you want. But you don't have to stop here. Another thing you can do is not say equal 1 here. You can say equals John and declare an enumerator using another enumerator. So for example, if we say John here, we're going to get the same thing. Let's, for example, say January and build again. Now the build is good. We can clear and run roster. We're going to see that month is 1. If we say Jan, we're going to also get the same thing. Let's say that if we build again and clear and run roster, we're going to see month is 1. So you can really use all these pieces of information to make your Enum classes work however we want. And I think we have covered all we really set out to do in this lecture. You should use Enum classes if you have some custom types that you want to represent in your C++ programs. And these types are going to have a range of possible values to represent them. You should know that all these enumerators are going to be represented by some kind of integral type under the hood. The default is going to be int, and the range is going to be constrained to the range of int. But you can customize that to whatever you want using this syntax here. And you can either expand on the int type or shrink that like we did this by limiting the range to 0 through 255. You can really do this however you want. One thing I don't think I showed you is that you can even use negative values to represent your guys here. But this is going to give us a compiler error because we are using unsigned car. But if we change this, for example, to be car and not unsigned car and change the value here to be 100, you're going to see that this is going to work. Let's try and build this and run. We're going to build with GCC. The build is good. We can clear and run roster. Now we have a -1 printed out and the size is 1 because we are still using a car to represent our enumerator values here. And we know that car is going to represent from -128, I think, all the way to 127. So these are valid ranges for our car type. This is really all we set out to do in this lecture. I hope you found it interesting. We are going to stop here in this lecture. In the next one, we're going to see how you can use using Enum. Go ahead and finish up here and meet me there.